Hey everyone, I'm Ryan. I'm one of the co-founders of Infer. In a previous life before we started Infer, we started about 18 months ago. I was a data scientist for about 5 years in a few different companies, market research, e-commerce, and before that, I did a PhD in applying machine learning to exoplanet atmospheres, so sort of aliens and astrophysics and things like that. So it was all very fun. And Today I want to talk about well, I'm going to give a demo of the tool, but through the lens of something that we call the blank canvas problem. And I'm sort of going to use this problem as a way to illustrate what Infer does and why we've built it. I mean, the TLDR is that we're essentially trying to help analysts use machine learning techniques to do their job better, faster, understand data quickly and deeply, and be able to productionize predictive models very easily. And yeah, I'll talk about how we do that. And the reason why we started it is because we felt as a data science team that we could see a lot of kinds of analysis like driver analysis or like retention analysis and things like that that really belong with business intelligence teams. So people like business analysts who want to understand how the business is doing. Usually, what happens is that those kinds of jobs get lumped into to data scientists. Those ad hoc works, and really, what we felt was that the teams that want to do these most should be the ones that are enabled to do them. And so the lack of knowledge and tooling out there for analytics teams to do these kinds of analysis is the reason why we started Infer. We want to basically empower people and democratize machine learning for people that you shouldn't need to have a PhD to be able to apply machine learning to retention analysis, for example. Cool. So, uh, what is the blank canvas problem? So this is actually not a tech problem. It's a life problem. The blank canvas is when you start any project. So it could be writing an essay or writing a presentation, and this is me writing the start of my presentation that I'm giving today, and the big pain is basically like, where do I get started? Like, I have all these ideas, like how am I going to formulate them? And starting is always the hardest part. And obviously, this is an analytics talk and an analytics tool. So why am I talking about this? I mean, to talk about why this is a problem in analytics, let's maybe talk about data analysis in general. And you can say that data analysis is a journey from question to story. So got these sort of 5 steps. Maybe there's 6 or 7, maybe there's 4, but this is how I've broken it down. So you've got ask, you've got prepare, process, analyze, share. So generally, you start with a question, you ask a question, and you're taking these steps um, to actually share some kind of analysis or some kind of answer to your question or your hypothesis. And yeah, it's about preparing the data, processing that so that it's in a nice form, analyzing it, maybe like reevaluating again, like what was the question I was trying to answer? Maybe I should be asking a different one. There's this whole sort of scientific process to analyzing data. And basically what we wanted to do was say, okay, for analysts, the problem here is that you've got lots of data, you've got like different questions, and you have no answers. Um, and what we want to do is enable people to basically start at the finish line. So can you go from asking the question all the way to having the answers and being able to share those answers as quickly as possible? So basically going from ask to share like this. Uh, so yeah, Infer, we are trying to reimagine machine learning for analytics and be able to help people effectively move faster to insights and to be able to share insights to answers very quickly, sorry, to questions very quickly, and be able to allow analytics teams to do more. So we always say that we are reimagining analytics with AI and ML at its core to allow a radical shift in what can be achieved with data. So we have a whole bunch of different things that instead of talking about them, I'm just going to show you them in the demo. So I'll just move through these pretty quickly. But basically, we wanted to build a platform where you can connect your data, and the data should be from anywhere. So it could be in a data warehouse, it could be from Salesforce or even a Google Sheet or something, or CSV. It shouldn't really matter where your data is or like almost the maturity of your stack. You should be able to utilize it somehow. There are companies out there just using Excel, for example, and they are getting by. And we want to enable any of those companies to be able to up their analytics game. We have this idea of coworker, which is, of course, the generative AI element, which is helping people use our platform to do more machine learning with your data. It'll become clear once I actually do the demo what this means. So we're all about getting to insights quickly. We want you to be able to create a data story or create a canvas from those insights so that you can share them. And we want you to tell your story. So obviously, we can get you to a filled canvas as quickly as we can, but then you'll want to tune it yourself. You'll want to like reword things or like update some graphs and things like that. And at the end, we allow people to schedule any kind of analysis that they've done or any kind of predictive model that they've created, and then write the results to anywhere. So, so you might have a churn analysis model that, or a lead scoring model, and you wanted to run every night and pull data fresh, and then write those predictions to Salesforce or to your data warehouse or wherever. And we really didn't want to limit anyone to any particular use case. We wanted it to take up as many solutions as possible. So you can do pretty much anything in our platform with tabular data. So like churn analysis, text analysis, customer segmentations, forecasting, lifetime value, credit scoring, like basically anything that you can think of, you should be able to do it with our platform, unless it's video or images, I guess. So yeah, we're trying to turn the last mile of analytics into a sprint. How are we doing this? This is a new technology. We have an extension to SQL called SQL Inf. And the idea is that we're taking any dialect of SQL and then we're extending it with new commands. So you can see here we've added a new command called predict, and the predict will take a column here, in this case churn, which is defined in the customer table, and it will actually build the predictive model and then start making churn predictions. So if you got new customers, you'll be able to evaluate how likely they are to churn next year. We wanted to make it completely generalizable, so that and sort of human readable. So you can read this pretty simply, right? So it's literally get all the data from customer, predict churn, right? It reads like English. Likewise, if you just change the column name to total spend, now you can actually estimate how much a customer is likely to spend over their lifetime. And so being able to move around different columns and different types of predictions so easily, that was like one of our main goals, to redesign machine learning to make it accessible, so that you don't need to know what XGBoost is or like hyperparameter tuning. And of course, you can actually do these things under the hood. We give you options to do that, but we want to make the default settings is sort of accessible to everyone as possible. And then, yeah, this just extends that, so you can see that it really is very easy to predict anything, basically. And we say that basically being able to predict or understand the past is predicting the future. With lots of commands, you can do clustering, sentiment analysis, topic analysis, forecasting, and yeah, this is a sort of summary of the language. So it's all built for analysts. It's all on GPUs. We're using very powerful machine learning models like XGBoost and Profit and large language models, and we're extending any variety of SQL. Okay, so I'm gonna move to the demo now. Oh, actually, one thing I didn't mention is that we also have a DBT adapter, by the way. So you can go onto DBT and you can connect in this language and extend all of your DBT models with with predictive models and clustering and so on. So you can see here it's very easy. You can just start using these keywords here that you wouldn't have had before. Um, Anyway, okay, I'll do a quick demo then. So this is the platform. Here you can connect all of your different data sources. So you can connect your data warehouse. There's like APIs and integrations to like, Google Drive and Salesforce and HubSpot and so on. Maybe just show you how um, how to just add any sort of data source. So you can just click on this button here and you can like drag and drop even just CSVs, or we've got a few coming soon buttons. Actually, these do work. We just haven't enabled them. Um, and Here you can see, Salesforce and Snowflake and BigQuery and Azure. You would just click here and upload your JSON files or do whatever kind of configuration you need. So we've got a few data sets in here. There is two BigQuery instances. It's just got lots of public data sets out there in this one. I obviously can't show you any client data here, so these are all sort of Kaggle-ish sets of data. But they're some of them are pretty realistic. And what I'm going to do is I'm going to start a new project. And once you start a new project, you can select a schema from your BigQuery instance. So here I'm just going to take this bank customer data set, and in here there's some data about whether the bank customers have churned or not. Once we set up a project, when we first gave this to people, we realized that they had to go and like read all the docs. You had to like go in here and read all about the language and figure out like, oh, okay, this is the syntax and these are all the things you can do, and it takes a little bit of a while. It's kind of like learning a new programming language, even if it is designed to be simple. But the problem with that is that people don't really want to learn another new thing, and so can we accelerate their first use cases without them having to go and read things or copy and paste bits of code? And so what we did is we implemented this thing that we call Coworker. And basically what Coworker will do is it will go and it will read the selected schema and it will look at all of the tables and the columns that are in there. And it will then suggest kinds of analyses that you can do with our new language. So this usually takes maybe like sort of 30 seconds to run. There we go. Yeah. And so you can see already there's a few different things you can do here. There's a lot of predictions. There's also a segmentation model here. So this is like clustering basically. If there were time columns, it would have suggested forecasting, and things like that. So the idea is again this sort of blank canvas problem of like, can we get to somewhere very quickly? So this is starting off by offering kinds of analysis that you can do, which is kind of like proposing questions or hypotheses. So here, you've got all these suggestions. This last one here is about predicting customer churn, and you can go in and actually you can see under the hood what it's doing. So we have two ways of putting in data, pulling data from BigQuery. So one is you can just use like a table picker, which is kind of a no codey, like simple interface, so that you can just like select all of these different columns. And then the other one is that you can write SQL directly in here. So this is also good if you have multiple tables and you want to do like complex joins and things like that. In this dummy set, there's only one table, so there's nothing to join. But you can do anything in here. And it's actually got quite a nice little autocomplete set of functions as well, which is nice. And what we do is you can check to see, oh no, this didn't actually work. That's a bad demo. Let me check. wonder if it's this particular data source. Sorry, this is a classic live demo stuff. See. What we might be able to do is check, there might be one here already. Hmm, something funky about this data set. Okay, cool. Sorry, I think it's also because I'm using the staging environment. Let's go back here. Uh, do, do, okay, let's pick this one. During analysis two. Probably should have checked my demo before trying to give one. Okay. Okay, it's working in production. I just should not be using staging for a demo. Okay, cool. We're good. Um, so what it was suggesting before was to do this, right? So here we are getting data, pulling it from the data warehouse, and then we are using this data. It's just almost basically like CT, where we're just pulling data here, and then we're going to feed this into the next line, which is our extended version of SQL. So you can see here there's a command for predict, which is not a normal keyword in SQL. If we run this, uh, things will start to happen. So it will pull the data from the data warehouse. Um, and on the fly, it will create a predictive model where it is trying to predict this churn variable. It's actually doing a lot of stuff here. So you can see, so there's this raw output, which is very good for, this is what would actually be written into like a data warehouse, or, if you wanted to write it back, or you can just download it as a CSV here. But you can see all of the data that went in, and then there's a few extra columns. So there's prediction and probability. And what this is doing is showing you the probability that this person is going to churn. Then because we built a predictive model, we're basically using this predictive model to be able to understand the data faster. So here, the predictive model gives you feature importance. So like how important are the individual columns to predicting churn? And so you can see here the product number, age, active membership, country, gender, and so on are sort of the highest rated things. You can also go in and you can like look at like precision, accuracy, if you wanted to be like a data nerd about these things. We've tried to bucket it so that it's kind of like clear, what's good and what's bad. Obviously, it's a little bit subjective on what the problem is, but we're just trying to offer some guidelines for analysts. And so you can actually start to go in and look at there are different ways of seeing the same data. So we take this is the age column, and we're plotting it in different ways, but it's effectively the same data. And so what this shows is that as the age of a person increases, as you can see the shape here. So when people are aged 18 to 27, there's about a 20% chance that they're going to churn at any given year. And you can actually see this like pattern here that as age increases, the likelihood of churning is also increasing. So, and it also, this hover will tell you what percentage of people are actually churning as well. So it looks like it's about 9% or something here for this group. And so yeah, if you're aged between 46 to 53, you're actually very likely to churn as opposed to much younger people. So whatever this product is, For some reason, they seem to be losing a lot of older customers. And you can do the same thing for like categorical variables here. You can see that the likelihood of churning for German people, for whatever reason, is much higher than in France and in Spain. And you can dig around more and more. You can look at all of the other things. You can we only show initially the first four most important variables, and then afterwards, it'll be the next most four most important variables and so on. And I think one of the coolest things that we have here is that we realize that people were spending a lot of time looking at this, we call it the evidence, which is like all of the different insights here. And you still need to sort of read it and think about it a bit. And we said, wouldn't it be cool instead to take the most important insights and then turn them into like story cards? And so I actually think this is one of the coolest things that we have in the product. So here you can see that there's this sort of complex relationship between the product number and the likelihood of churning. Actually, I think this is not a number of products, but a like almost like a subscription or like a plan ID. Anyway, but what we do is that we take all of the data that makes this graph, and then we create a card, which is basically just a natural language summary of whatever is in here. So, it says the data shows the customers one product have a mean churn probability of 50%. You can see here representing the largest customer group. Interestingly, customers with two products who make up 46% of the base have a significantly lower churn rate of 19%. So you can see that here. And it goes on to describe the rest of the chart. Likewise, it does the same thing here for age. So this graph that I showed before here, basically it says, there's the data shows a clear trend of increasing churn rate with age. Churn rate starts at around 7% in the youngest age group and increases to over 50% in the second oldest. This could be due to older customers being less tech savvy or less satisfied with the service or something like that. And then obviously what happens in here is that you might not think everything in here is relevant. Maybe you want to like get off this last sort of few sentences, or maybe you want to say, churn rate increases age. And so you can like edit this card and you can change this card to use, one of the other graphs if you wanted to do that. And then the idea here is that we're trying to solve this blank canvas, right? We're trying to get you both to the insights, but also to sharing the insights as quickly as possible. And so we added in this like story element, and so you can create these storyboards where you will add your cards. So we can add that one. We can add, maybe add this one here. And then you can see the story basically that you've created, and as well as seeing the story. So the reason why we made this is because it's completely linked to the original analysis. So you can actually go back to the original data and you can see all the query that's been used. You can see like the data that it came from. And you can also still interact with it. So it's an interactive piece that is shareable, that is like completely linked to the original work. So it means that you can go back and repeat that analysis, maybe with new data, if that's what you wanted to do, to see how things have changed. But yeah, it's a nice way of taking work and productionizing it without any extra work. Basically, is always what we're trying to do. And you can play these in a nice little presentational mode and things like that, and you can make them nicer. So yeah, the idea here would be you can share this with your stakeholders. You can save this as like an ad hoc piece of analysis. And let me just go back. And then usually the last thing you want to do is, so if you care about the oh crap, sorry, I went the wrong way. Oh, sorry, I didn't actually save this when I should have done. I'll just run it again. It'll take a few seconds. Actually, I can maybe show you another piece of analysis. Um, okay, here it is. Here. You can also see that this whole thing is extremely fast because it's all sitting on GPUs. So we've like really optimized the hell out of the speed of this. But basically, another third is it is XGBoost. It's just a GPU variant of XGBoost. And yeah, the last thing that people generally want to do is that they want to create a schedule, right, or a pipeline. Is maybe how other people say it. So like maybe like retention model and we want to make it very easy again with whatever work that you've been doing, basically almost exploring the data that you can very quickly then productionize both the insights about the story, but also productionizing the predictive model itself. So if you wanted this to run every night or every hour or whatever, you just select a time, say like how often you want to repeat it, every day, week, month, hour, whatever. And then you can choose where to write it to. So I've got a couple of different BigQueries here, or you can just write it to the Infer platform, which means it'll just, you just log in and look at it instead of writing the results into anywhere else. You could also write it into like Salesforce or HubSpot or Klaviyo or wherever your or Google Sheets, wherever your connections are. So it can be like very powerful, basically. And yeah, that's it. I mean, that you just basically just need to hit go and it will save this, but I don't actually want to create a schedule right now. Um uh yes. Um I think that's pretty much the whole platform actually. I can show you maybe some other kinds of analysis. There's also let's see. Yeah.
Hey Ryan, I had a couple questions that I know that'll probably pop up in like in people's thoughts as they're watching this thing. Is there a way to tune these models as you go, or are they just kind of automatically tuned?
Yeah, so how it works, so we have a whole bunch of basically like best practices. So, it does like it's XGBoost with a specific like set of hyperparameters, but we do like early stopping and like it's all properly like validated and things like that. You can change them. There are if you go to the docs, there's like options that let's see. So if you go in here, there's like all sorts of like, ways to override the default settings. There's also I think generally what people are asking, rather than changing particular hyperparameters of the model, they're usually saying, can you do like auto ML? Basically, like how can you maximize the accuracy? The default parameters do kind of prefer like speed over like absolute accuracy. If you need like the extra 2% more accuracy, it will take 10 times longer, basically, right? And so we were focusing on like the speed of iteration. Um, and then at the end, you can basically just say use auto ML equals true, and then it will run, I think, 100 models. It's either 100 models or 10 minutes long computation worth of models, whatever comes first. Um, so yeah, you can edit the pieces under the hood as much as you want. Yeah. Any
Awesome. And
more
you also
questions?
mentioned that you also mentioned you don't do audio and images yet. So when is that going to be on the pipeline?
Yeah. I mean, so we were trying to focus on like SQL data, tabular stuff. It's funny actually because obviously it's very I mean, you can store sort of image data and videos and things in a database. And it would be easy to. So like we've made it very extendable. So like people have asked us for new commands, and so we just add more as we go along. People have asked for like A/B tests or like causal inference methods and things like that we've just added more and more of over time. So yeah, I mean, if someone really, really wants some like image detection stuff, we can do it.
That was my trap question that I was saving for you. So that's the rest there at the top. So. Well, yeah. Is there anything else you want to show up in the platform before
Yeah,
we hop off of here?
I mean, there's all sorts of other things you can do. So I think another cool thing you can do is like the customer segmentation. I'll just do that, and then that'll probably be enough, and you'll have seen the sort of like variety of models that you can do. Um, let's see. So this is some data on like customer spending habits. Let's see. Maybe it'll suggest something already around segmenting this. Let's see. Also, apologies for the random live demo problems. So I feel like it wouldn't have been a demo without the random issues.
That's how you know
Um,
we're actually doing this thing live and not
yeah,
recorded.
yeah, yeah. Um, cool. So it's all just spinning and spinning. Okay, cool. Yeah. So you can see here that what it's done is it's going to create a segmentation model based on customer spending. So actually I think I've done this before. I think it's better if you do I think product categories gives you better, more interesting clusters. So I'm going to change it to that by product category. So let's run that. And again, cluster is you can read about the actual methods in the docs, but basically it's UMAP and HDB scan for like the data scientists out there. And part of the reason why we're using those is because you can also put them on GPUs, and so there you can get very powerful analysis that is also like sped up quite a lot. Um, it is this one is definitely much slower than some of the other commands. Part of it is you'll see in a second. So you see the model is run, and what the model is doing is this it's basically taking all of the data and then reducing it, and it's doing like a dimensionality reduction, and then clustering in that like reduced space. And basically what it will do is it will give each data point a cluster ID. So here you can see there's 10444, which means there's probably at least 5 clusters. Um, and it's churning away to turn this data into graphs. And I think the neatest thing about this, if it will finish, um, is that it will actually name the clusters for you. So instead of having cluster 0 or cluster 4, it will instead say something like oh, here we go. So you can see here, uh, UK casual cycling enthusiasts, for example. So or transatlantic shorts and socks enthusiasts. It comes up with pretty like fun, creative names, and then you can actually dig into like why did it name these things? This and so you can see here it seems like this is sort of like US and French cycling enthusiasts that are apparently purchasing things in the same way. Um, and the idea here is that it will show you how over-indexed this cluster is for the different states here, I guess, and for like other properties. So here they're buying helmets and fenders and things like that. So this is all like cycling stuff, basically. And you can some more helmets. So I think there's quite a lot of cycling stuff in here. But yeah, you can start to like look into these things, and they all come with descriptions, and you can create pretty cool little customer segmentations very quickly using this. Um, so yeah, anyway, that's probably enough. Probably enough demoing. Let's delete the bugged version. Um, yeah.
Yeah, well, awesome. Well, thanks, Ryan, for popping on and showing us around. I'll make sure that I'll post kind of your LinkedIn profile URL in the description so people can connect with you if they want to learn more about Infer. I definitely think it's a cool tool, and it's on edge of I think where things are going. We're just allowing more data people to have access to these things that they didn't used to have access to, which I think is really neat. So.